Today we're going to talk about how to model quadratics in the real world setting. So this video goes through this notes packet, so make sure you have this packet on your desk so you can follow along. So a lot of times when we're modeling quadratics are used in the real world when it regards to falling objects or throwing an object like a basketball into a basketball hoop, that's a quadratic. Or if you throw a ball up in the air, it's going to come back down in the air. That's all making parabolas and quadratic equations in the real world. So a falling object model, it says when something is dropped, you can estimate its distance from the ground using this model. So this model here is like the generic way to calculate a falling object. So if we talk about what each of those things mean, H stands for the ending height. Okay, and T, hopefully we all know, stands for time in seconds that an object falls. The time an object falls. Okay, so H is my ending height. T is the time in seconds that an object falls. And S in this equation is the standing height in feet. So it's the standing height, so the initial height, the standing height in feet when the object is dropped. When object is dropped. Okay, so this equation is represented when it's regarding a falling object. So if we go ahead and we start looking through some of these examples, let's look at example 1. It says a boulder falls from a cliff in a storm. The cliff is 70 feet high. How long will it take for the boulder to hit the road? So if I'm looking at this, I'm looking for how long, that's t. So obviously in this equation up here, I'm looking for t. So when will it hit the road? So when it hits the road, so if you think about it, if there's a boulder, it's falling from a cliff, when's it going to hit the road? My road is at 0, so that's the ending height. So if I start plugging some of this in, and I know 70 feet is where the boulder started, so that's going to be my standing height, my starting height. I said standing, and I think I meant to say starting up there, but standing height, starting height, you can figure it out. So I'm going to write this equation down. And I'm going to plug in what I know. So I know 50 is the starting height, so that's S. I know I'm looking for T, so I can't plug anything in for T. And it's going to hit the road. That means its height is 0. So if I look at this problem, all I have to do is solve for T. So what would I do first? Well, I subtract 70 on both sides. So I have negative 70 equals negative 16 squared. So from here, I'm going to obviously divide by negative 16. So negative 70 divided by negative 16 is 4.35. Oops, 375, excuse me, t squared. Sorry, my dog will bark in the background. But it adds flavor to my video, which is perfect. So now I'm going to square root both sides to get t. So t equals 2.09 seconds. So basically, 2 seconds and the ball will hit the ground. And obviously it's plus or minus because when you square root, right, you have to take plus or minus. But in a real world setting, you can't go negative time, so it's positive. So I always end my word problems with a therefore sentence. So I say therefore, hopefully you remember that symbol from geometry. The boulder will hit the road at 2.1 seconds. Okay, so hopefully that's okay. Let's go ahead and let's keep going. Let's look at number 2. Number 2 says a ball is dropped from a 6th floor window at a height of 70 feet. When will the ball hit the ground? So I'm looking for when the ball will hit the ground. So I'm looking for T again. The sixth one, when will it hit the ground? When it hits the ground, it has a height of 0. And then, so that's H. And then it has a height of 70 feet, so that's where it's starting. So that's go ahead and plug this in. H is my end height, which is 0 feet, negative 16t squared, plus the initial height, which is 70. And I'm going to do the exact same thing all over again. I'm just going to solve for t. So I'm going to subtract 70 first. Sorry, my dog is barking at nothing. So if I subtract 70, I get negative 70 equals negative 16t squared. So now I'm going to do it again. Negative 70 divided by negative 16. And I get the exact same problem as above. I hope you're noticing this. It's literally the exact same problem because my standing height is the same. So let's change 70 to 80 to make it just a little more fun because otherwise you're doing the exact same problem. So that's going to be negative 80. I'm totally just changing this problem. So negative 80 divided by negative 16, that's 5. So I have 5 equals t squared. So now I'm going to square root 5. And I get t equals plus or minus 2.23. So if I write a therefore sentence, therefore the ball will hit the ground at 2.2 seconds. Oops, and I totally just scrolled. 2.2 seconds. Okay. Rounding, I'm not really super picky on. If the problem might ask you what to round to, but if it doesn't, the tenth is fine. It really doesn't matter. Okay. Hopefully you're doing okay. Let's go ahead and let's keep going. It says, example, the height y in feet of a baseball t seconds after it is hit is given by the function this equation. Find the maximum height of the ball. Okay, so if I think about this, if I have a person and they're going to hit a ball, the ball starts here, right? And it goes up, and then it goes down where it eventually hits the ground. So I want to know, and it's modeled, this parabola that I just sketched is modeled by that equation. So I want to know what is the maximum height. So the maximum height is right there. So the maximum height is also classified as what? Well, that's also the vertex, right? This is the max height, which is also the vertex. So if I give you this equation right here, how do I find the vertex? Well, I got to find the x value, so I got to do the axis of symmetry first. So that's going to be negative b over 2a because that's standard form. Yay! You thought this stuff went away, but it doesn't. So I'm going to have negative 96 all over 2 times negative 16, because that's 2 times a. So I have 2 times negative 16, and then I'm going to do negative 96 divided by negative 32, and I get 3. So my x value is 3. So how do I find my y value? Well, I plug it in. So, oh, I don't think I meant to hit that button. Oh man, and now I don't know how to get back to my pen. Let's see. Hold on a second. You're probably sitting there laughing at me. Tools, maybe? No. All right, I'll pause this for half a second to figure it out. Okay, so I failed, so I opened this up instead. So we have 3. So I'm not going to take 3 and I'm going to plug it in. So I have negative 16, 3 squared plus 96 times 3 plus 3. And because I'm allowed to use a calculator, I'm going to totally cheat. I'm going to type all of this in my calculator and I'm going to hit enter. Because you have all been excellent at doing this. So you should get 147. So my maximum height is what? So that's my vertex. So that's this point right here. So what does this represent and what does this represent? So this represents x. So if I come over on the x-axis, that's 3. And if I go up on the y-axis, that's 147, right? So through x represents time. So at 3 seconds, my maximum height is at 147 feet. So therefore, my max height is at 147 feet. Okay? So hopefully this is okay. This makes sense. I want you to go ahead and I want you to try the next one. When you finish it, pause it and I will go over it. Alright, so if we go ahead and we look at this, it says, while marching, a drum major tosses a baton in the air and catches it. The height and speed of the baton after 2 seconds is modeled by this equation. So I'm going to use that equation. And now my pen's working again. Hooray! So it says, find the maximum height. So when it's asking for the maximum height, that's just asking for the vertex. So it says, okay, what's the vertex of this problem? So how I find the vertex is I got to do negative b over 2a first. So I have to do negative 32 over 2 times a, which is negative 16. So I have negative 32 over negative 32, so that's 1. And then I'm going to plug that in. So negative 16 times 1 squared plus 32 times 1 plus 6. And when I type all that into my calculator, I better get 22. So my vertex is 122. So the maximum height is always the y value. So I'd say, therefore, the max height is 22 feet. Okay? So now if I look at it, it says when is at its maximum height. So when it's at its maximum height, well, that's the x value of the vertex. So at 1 second. Okay? So the other wonderful thing is you can also do this in your calculator, which is why I have my calculator open on the screen over here. So if you go to your calculator and you press y equals, and you type in this equation, so and instead of t, we're going to use x, negative 16x squared plus 32t, which is x, plus 6. Okay? So now I'm going to hit zoom 6 in case somebody messed up the formatting of my calculator. It always brings it back to standard. And I'm going to watch a graph. So I'm looking for the vertex. Notice, do I have the vertex? No, the vertex is somewhere up here, right? So I'm going to hit zoom and I'm going to zoom out. So 3, and then I'm going to hit enter to zoom out till I see my vertex. Hopefully I see it. Oh, there we go. There I see it. So my vertex a maximum or is it a minimum? Well, it's a maximum. So I'm going to do second, trace, and I'm going to hit 4 because it's a maximum. And then I'm going to go to the left of it. So I'm going to put my pencil on, I'm going to put my blinking cursor on the vertex and go to the left, hit enter. Now I'm going to go to the right of it, hit enter again when it says guess. And sure enough, I got 122, which is exactly what I got over there. If I scroll up, can you practice with that one? So I would do the exact same thing. I'd do y equals, and I would do negative 16x squared plus 96x plus 3. And then I'd hit zoom 6. I don't see it, so I'm going to hit zoom 3 to zoom out. Zoom 3, try again. And there it is. It's hard to see. Another way you can do this if you don't like how this looks, you can so notice you only want to be in the positive y values, right? I don't care about the negative y values. If I hit window and I go down to my y min, which is right there, and I just type in 0, and then I press graph, changes the window to where it maximizes just the top, and that's still kind of hard because notice it's really skinny, so I don't really need as wide out on my x's. So if I hit window again, and instead of negative 160 to 160, what if I just do negative 10 to 10, which is standard, by the way. Negative 10 to 10 is standard. And if I hit graph like that, oh, look how perfect it is. So it's a maximum, so second trace 4. Put my blinking cursor on my vertex. Now I'm going to go to the left of it any number of times, it doesn't matter. Now I'm going to go to the right of it any number of times, it doesn't matter. And I'm going to hit enter again, and I get 3.0000147, which is basically 3,147, which is exactly what we thought. So hopefully you are okay with this. Let's go ahead and keep going. If you want to write down the steps for how to do this in the calculator, I strongly recommend doing so. I have given you a lot of problems where you've had to graph an equation, but you've never had to give me the actual equation if I give you the picture. So we're going to work backwards here. So when you have a picture, it says write the equation. You can pick what function, what form you want to write it in, but I always start writing it in vertex form. So if I start writing this in vertex form, I'm going to say, well, my vertex is negative 5, negative 5, 8. Okay, so I'm going to say y equals, I'm going to leave a blank for a, and then it's going to be x plus 5 squared plus 8, right? So now I need to figure out what a is. So how I would figure out what a is I would just pick this point. So I'm going to put a here. And I would use this point right here, which is negative 3, 4. And I'm going to plug negative 3, 4 into y and x to find a. So I'm going to plug 4 into y. Oops, not that. And I'm going to plug negative 3 into x. And I'm going to solve for a. So I have 4 equals a times, that's 2 squared, which is 4, plus 8. I just did that in my head. And now I'm going to subtract 8 on both sides. So I have negative 4 equals 4a. If I divide by 4, a equals negative 1. So if I go and I now write my equation, y equals negative 1, and then my vertex. And I'm done. And then obviously if the problem said write it in standard form, I would then have to double distribute this and then distribute negative 1 and then add 8 at the end. But I'm not going to do that. I'm just going to stop here. So I want you to pause this video and I want you to try 2 on your own. When you finish 2, I want you to unpause this video and we will go over it. So I'm going to write my first equation with my vertex, which is x minus 2 squared minus 7. And then I'm going to take this point and I'm going to plug it in to find a. So 1 goes in for y, 4 goes in for x. So 1 equals 4 minus 2 is 2, 2 squared is 4 minus 7. So I'm now going to add 7 to both sides and divide by 4. So a equals 2. So my equation is y equals 2 times x minus 2 squared minus 7. So hopefully you're okay with that. All right, and the other thing we want to talk about is how to write an equation if I give you the roots. So if I look at this problem here, and I want the roots, I want to put them back into factored form. So if these are my answers, these are my x-intercepts, because that's what roots mean. To put them back into factored form, I got to do the opposite. So I'd have to do y equals x minus 2 and x plus 5, right? Because remember when we had this before and we split them up, we would say x equals 2 and x equals -5, which is exactly what we're doing now. We're going in the opposite direction. So now I'm going to go ahead and I'm going to double distribute. So I have y equals x squared plus 5x minus 2x minus 10. So now I have y equals x squared plus 3x minus 10. And I'm done. And that's how I put it in standard form, which is usually when you have the roots and you're looking for the equation, you usually want to put it in standard form. So when I have imaginary numbers, it makes life a little more complicated. So notice I have x plus 3 plus 2y and x plus 3 minus 2y. So I just took the opposite of both of these and I put them in, right? So here I'm going to do x minus, and then I'm just going to write 3 plus 2y in parentheses. So I got to take the opposite of that. And then I have to do x minus 3 minus 2y because I have to do the opposite of that one. And because I have to do the opposite of both of them, I have to do the opposite of two terms. That's why I put them in parentheses. So I know to distribute that negative. So I have x minus 3 minus 2y. Then I have x minus 3 plus 2y. Okay? So now I'm going to triple distribute. So I have x squared minus 3x plus 2xi minus 3x plus 9 minus 6i. And then I have minus 2xi plus 6i minus 4i squared. Oh, all right. So let's see what I can cancel out. So I have positive 2xi with negative 2xi. I have negative 6i with positive 6i. And I know I squared means the same thing as negative 1, so I cross it out and change that sign. Now I can add them up. So I have y equals x squared minus 6x, because negative 3x is negative 3x. And then I have 9 and 4, which make 13. So all I'm doing is I'm going backwards. I gave you the roots, the x-intercepts. You're going backwards to determining what the equation would be. So I want you to pause this video and I want you to try number 3. And when you finish with number 3, I will put my answers on the board. So the answer to number 3 is right there. If you are confused, make sure you ask me or a neighbor to help you out. Otherwise, we are done with this portion of the video.